to just do a little bit of a brief introduction on you, and just introduce you and your research. I think many people here know that you lead research for VITA Lab. And before that, just reading from your bio, you spent several years at Stanford University, which is where I met you as a postdoc and research scientist. Your research lies at the intersection of computer vision, machine learning, and robotics as applied to transportation and mobility. And in 2022, you were recognized as one of the 100 most influential scholars in computer vision over the last 10 years. Your research team has received editors.
It's not star. I think I heard star, but it's just more citation. It's just based on some numbers of citations. It's not. It's one of these fake things.
I wouldn't discount your accomplishments because I have much more to read, which will show that you are certainly downplaying things. Your research team received the Editor's Choice Award from the Journal of Image and Vision Computing for their work on all of your work on human motion prediction. And in 2019, the honorable mention at an ICCV workshop for your work on human pose estimation. Other honors include the CVPR Open Source Award for your work on retina-inspired image descriptors, and the IDC DSC Challenge Prize for sparsity-driven algorithm that has tracked more than 100 million pedestrians to date. Your work has been licensed to several companies and covered internationally by the BBC, ABC, PBS, Euronews, Wall Street Journal, and other national news outlets around the world, including my own current podcast. Congratulations. And you co-founded multiple startups, including VisioSafe, and elected one of the top 20 Swiss venture leaders in 2010. So thank you very much for doing this. I'm a little intimidated, to be honest, even though I've known you for many years, but very, very impressed by all of your work as I had a chance to sort of research and look into it, and very excited to chat with you more about it. So thank you for doing this.
Thank you.
So I wanted to just sort of start off maybe with a little bit of background and ask you what drew you to the field in the first place. So I know you grew up in Paris, and so maybe you could give a little bit of a background on your history and what and how you came to be here right now.
I think it's thanks to my father. So I guess the question is how I entered the field of AI, right?
Sure.
It was my junior year. I did an exchange program at SMU, Carnegie Mellon in Pittsburgh. And so we were a few students from Europe going there. And after a few weeks, we saw this career fair on campus. And all the students were like basically going over all the stands and finding internship for their summer. And we're like, oh, wow, that's interesting. Even a second year student or first freshman year student work over the summer. This is not common in Europe. We actually do other stuff over the summer. And then we are with my friend, we said, okay, let's do it. Why not? It's a great experience. And we did not find anything. Zero internship because we had zero experience compared to all our other American students. And then my father had a company in the Bay Area. He said, I accept you guys. So we all went to his company. And back then, it was quite innovative. We were in charge of recognizing license plates in parkings of San Francisco. So this was 2002. So 20 years ago, or more than 20 years ago. And it was, nobody was doing that. So he had this project with all the parkings of San Francisco. In Japantown, in fact, we installed the first one. And I was working on this over summer. I discovered machine learning, pattern recognition back then, it was called. And I loved it. So I decided to specialize myself in computer vision and AI since 2002, thanks to this project that my dad gave me over summer.
Amazing. What happened to your fellow intern?
So one of them joined Facebook as a very, very early employee. So I can let you guess what he became now. He retired, basically. And yeah, lost track of the others, but it was a great experience, and I guess I made the wrong choice of not joining Facebook, I think.
I doubt it. I'm sure your father's very proud and happy he played such a pivotal role in getting you on your start. And then with the EPFL, how did that come about?
You mean why I joined EPFL as a faculty, or?
Yeah, and how did the research lab come into being?
So EPFL is an amazing university in Europe. And so Switzerland is very small, and the government is investing a lot of money in education, and they are offering students and also faculties everything they need to be able to pursue their education and research. And so hence it's an amazing place to be able to contribute to science, and they treat you very well. And so thanks to all these opportunities, fundings of the government, we are able to attract great students, and also convince people to remain in academia, do research, and they give us all the funding required to do that. So it's a great place to be if we want to still remain in academia and work on research that is extremely trendy and competitive also with the industry. Yes, I did my studies at EPFL and left to the US, and you should come here. I mean, Lausanne, Switzerland is so beautiful, and that and I realized that there was an opportunity to come back here, and I decided to take it. It's dark, but I would have shown you the lake, so you would have understand why.
I think I've seen it. I think I've seen it. It is
Actually,
very,
I can simulate the lake. Wait 1 second. Voila, I have another.
oh, that's beautiful. Let's keep that one.
Okay.
It's very calming.
So this
Uh,
is our robot in the lab that we're working with.
and so I know I'm excited. I have so many questions. So um, I guess, can you explain a little bit? I mean, this has been your field of research almost your entire professional career. And with VisioSafe, which I remember was one of your earlier startups, it connects, right? Because you were using human sensors to track motion. So what was it that you sort of took away after building that company that made you want to sort of delve deeper into certain questions?
Um, so yes, what I mean, the company is out of my PhD. So I was doing a PhD on the topic of detecting and understanding humans. And back then, simply being able to locate humans or detect humans with a camera was a big deal. So usually you need to, I don't know, put a sensor on the person or have expensive hardware set up to locate, detect humans. And back then we wanted to reduce the cost and do it with a camera. So this was the topic of my PhD, and we were able to transfer it to a company and scale it with respect to its application. But then we're just locating humans on the ground. We're just like tracking their trajectories and things like that. But there's so much more you can do with this type of technologies, and hence I felt like there is so much to do with respect to the research, with respect to the technology, in many applications where if you only do one company or one product, you will not be able to address them. So, the first thing they teach you, focus, vertical. But there were so many other opportunities, and that thanks to a academic hat, a professor hat, you're able to address them through your students, actually. And so that's why from VisioSafe, I decided to go back to academia 100% to be able to do more, address more problems, solve more problems than just a single one.
And fast forwarding to today, what are the kind of key research problems that you're focused on?
So our lab is really interested in still better understanding humans, but focusing on their mobility, how we move, and help assist humans to move in an efficient, safe way. The most common applications are how to develop a self-driving car, how to develop delivery robots, how to even assist paralyzed human to walk again, and how to reduce human error in their mobility and make it cost effective, so that basically mobility is a commodity, universal right for everyone. Nowadays, it's not the case. We cannot go anywhere we want at any time. Sometimes it's too costly. Sometimes it's not sustainable. We don't want to, impact the Earth, or it's not even safe. Who knows what will happen? But we realized that, with COVID, when they forced us to not move, how much mobility is a big deal for our society, for our humanity. So our lab is trying to make our mobility something that is really, really accessible to all.
And it's actually, it seems in a way it's deceptively simple sounding, movement and how humans move. But I was rereading an old economist or economic business book that I had from many years ago, which talked about how crowds move and how sophisticated the interactions are between them, and how incredible it is that we intuitively predict what other people are planning to do as you walk through the crowd. And in fact, I think that that excerpt was stating that, interestingly enough, the more complicated and hectic the crowd, the better humans become at weaving through and navigating it. And so I know from your TED Talk, which was fascinating, that was a big area or something that you focus on in terms of programming, how to simulate those same instincts that humans have.
Yes.
Yeah, and I guess, oh, no, go ahead. No, it's just, I was just curious, if the subject matter to you became, it sort of increases in complexity the more you learn and the more you understand.
Yes, it's quite fascinating, right? So in fact, this is also related to one of your previous question, what changes from like VisioSafe or the company of detecting, locating to now. Now our focus is to learn to predict behaviors, learn to predict motion. It's no more detecting. We are actually quite good in detection now, locating, but we realize that this is not enough. Many applications. So if you want to have a system or a machine that will interact with humans or coexist, we find out that we need to develop the same cognition as humans, and we subconsciously actually predict a lot of the things that happen around us. We're not aware of it, but many of the decisions that we take are based on subconsciously predicting the future. As you said, walking in a crowd, even driving, entering a roundabout or things like that. And then yes, in respect to our research, we have started to develop new methodologies that could potentially match human performance in predicting, and it's not that easy. This is the current challenge of AI, to be able to predict as much as human, as good as human. We don't need to predict the world perfectly, because we cannot. We have free will, and this is actually the beauty, that we have free will. But the question is, given this uncertainty of that the free will brings us, can we model it in a way that machines can also take actions based on this uncertainty around us?
And I know we spoke about this over the phone briefly, but I had asked you how the developments in text-based AI and LLMs over the last year have affected your research, and really research across all subfields of AI. And I remember you explaining that it had a profound effect.
Yes, absolutely. I guess the first thing that was very, very interesting with a large language model, or what these companies did, is they invested in developing big models using a lot of resources and a lot of data. So they decided to scale up our methodologies. So with respect to the method, they used things that existed, that were publicly available, everything was available, but they decided to take the bet of scaling all these all the methods. And what I mean by that is, long time ago, even if you had more data, it would have not led to better performance. Our method was saturating, even if we have more data or a lot of compute, we could not take advantage of it. Yes, we can try again on different parameters, but the performance is still the same. Over the past decades, we realized that we have methodologies like deep learning or neural network, that if you use a lot of data, even more data, the performance still improves. And you need a lot of compute, and if you invest on a lot of compute, it's worth it. And that's what they show us. They were willing to invest millions, 100 millions, or maybe billions, just on compute, on collecting data, and pressing enter and see what happens. And they showed us that yes, it's possible to learn to compress the web almost, and really be able to solve tasks that we did not think that they will be solved this way. And this was quite impressive, that you could learn a latent representation of the internet, of our language, of our knowledge, that is written in a way that you could potentially, interact with the system, ask questions, and fool you that this is a human answering you, across broad range of domains. That was also very interesting. Back again, a long time ago, we thought that for each domain we need a specific model. Now they show with one model, it can be quite general. We still, on the research side, they are still showing that if you focus still on one domain, you have a better performance than the model that is generic. But still, it's quite very impressive that a generic model can still be competitive.
And when you say domain, you mean text-based versus computer? Like, is that what you mean?
No, I mean, for instance, domain is coding versus Wikipedia, or like answering, or like a domain like physics versus medicine versus law versus something else. So suppose that I want, so, you know, I mean, in this large language model, at the end, the way they work, they predict the next character or next word. So when you try to predict the next word, predicting the next character in coding is extremely different than in Shakespeare, right? So you can give a lot of data on Shakespeare, and yes, I might be able to do a good job, but that will not help me predict how I code. I mean, the language of coding is extremely different. You know, I mean, it's not following the same structure as I write text. But they were potentially showing that I don't care. I'm gonna take all the text that is available within programming languages, within text, from Shakespeare, from, you know, books, from, I don't know, blogs, Twitters, maybe Wikipedia, and I will still be able to learn things across these domains.
Interesting.
But
And so how has everything then, how is this all manifested in terms of your approach, your lab's approach? Has much changed in the last several months, given these developments?
yes, absolutely. One huge paradigm shifting, I would say, learning is that these large language models are also called foundation models. Basically, what they mean is you need a huge model with a huge amount of data and compute, and you have something that is quite powerful. But this model is extremely expensive to obtain. A research lab cannot necessarily have it, or a startup. But if these models are available to startup or research lab, and they have their own specific application in mind, they can take advantage of it to fine tune it, to adapt it to their specific application. Again, before this paradigm, when I wanted to, let's say, have a method that can summarize text, maybe I would have collected my own data and my summary, and I will have tried to learn a model that will do this. But now what I can do, I can say, okay, I'm going to take this huge model, but I'm just going to adapt this one to do my specific task. And by adapting the huge model to my task, I do much better than me developing from scratch a model on this data. So this is a paradigm shift. But what that means is maybe I will have to give something to this company giving me the big model. You know, like they call it GPTs, OpenAI. So you have the big GPT, and then you can create your GPTs for your own task that will still take advantage of the big model, but you'll need to adapt it, fine tune it for your own specific task on your own data. That's great. But it will work much better than you doing something from scratch. So this paradigm is very interesting, and in respect to computer vision or other things, we're also wondering, are we going to have a foundation model for image the same way that we had for text? Are we going to have it for audio, for other modalities, other signals, you know? And the question is, okay, suppose that the world will become like this. So some companies or maybe academics will join and put big models that are quite expensive, but you compute them once, and then everybody else take them and for their own task fine tune them. And is this the right way of learning and doing machine learning? That's the question, and this is what we're currently looking. Maybe to be able to disentangle like these huge foundation models, like tasks that maybe are generic to everything, and then come up with a method that can adapt this model to your specific tasks.
And are you fine tuning? You're not doing that yet. You're not fine tuning off of any of these foundation models yet, or you are?
Yes, we are. Yes. So the correct word is fine tuning. Some people say alignment, you know.
Mhm.
But yes, so we are, and we're also on the same time looking at what could be a good foundation model, what the foundation model should have as property to be able to be used to do fine-tuning on many other tasks.
Interesting. There's one a little off topic, but there's one of the entrepreneurs in this meetup network who is working on kind of data annotation in that particular segment of the market. Is that something that you and your research team think about in terms of the data annotation, the collection, everything that the inputs that go in?
Yes, absolutely. One thing that is extremely clear now is that data is extremely important, and the quality of the data. One thing that the first time I saw ChatGPT and OpenAI results, they were claiming that they basically took all the web, whatever that existed, they learned to predict the next word, and then they adapted, align it so that the answers are good. And we thought that when you take all the web, you have a lot of noise, you know, it's all kind of content, but it's okay. You take everything, and for some reason, the model is able to do this job. And now we realize that this is not really correct. They have cleaned the data a lot. So they have curated the data a lot. At least other companies that are trying to get the same performance, to get there, they realize that they have to clean the data. You cannot just take data randomly at scale and hope that, even if there is noise, it's okay. And so you need companies that will actually do this for you, to clean the data, to maybe label the data for you, obviously. And you want to be smart because this is part of the cost.
Mm-hmm.
We are, maybe I can give you a longer answer. Before, again, large language model, GPTs, all these things, the common practice in machine learning AI was supervised learning, which is I need the ground truth data or labeled of what you want me to learn. For instance, if you want to recognize cat in image, you need a lot of images of cat where humans have told you this is a cat. So, you ask humans, is this a cat, not a cat? And you collect a huge database. And this is really called supervised learning, and you give this data to your method. In ChatGPT, it's a bit different. You don't need to ask humans, for instance, what is in this image or what is this text about. You just take all the text that is available and you try to predict the next word. So you don't need, a human labeling what this word is because it's available. You're just predicting the signal. And you could think that this is a bit cheaper because you don't need human to tell you what is this. But it's not, because you need to then take good data, take basically text that makes sense and remove text that do not make sense. That has also a cost. So having elegant ideas of how to clean data or how to label data is also part of some research. A lot of people suggested games, for instance, or CAPTCHA, Google, whenever they ask you to, is this a bus or not a bus? This is great data to get this information. So there are a lot of ideas, or Amazon Mechanical Turk, you put these things and crowdsource and you take advantage of all this. Yeah.
Okay. And maybe I'll pull it back out and more into the application of your research. And just curious if you could kind of share if any of the research that you've been working on and your lab has been working on has been applied in any kind of real transportation systems to date. Anything you'd be curious to
Yes.
share?
We have a lot of partners from the industry that are indeed interested in our research and using it. Big companies are using some of the methods that we develop, like I don't know if I'm allowed to cite them, but but really big companies, and also a lot of we have a lot of collaboration with the automobile industry, and to develop the AI of a self-driving car. And over there, it's really a collaborative work. They have a lot of data. They have, all the vehicles, and we develop the methodologies, the algorithms to be used for them. And then in the transportation domain, also, like railway companies are extremely interested in our technology to understand how commuters use their stations, their train stations, but also how they behave within the trains or within their buses, transportation companies. And we also have people using it in completely different domain, like sports. We have a lot of a startup working with us to do sport analytics or coaching, how to use this technology to give good feedback to the coach, to be able to predict what will happen in the game. And then healthcare, obviously, a lot of application in healthcare. One of our very exciting collaboration is as how to enable paralyzed human to walk again. So they are able to put a chip in there for humans suffering of a spinal cord injury, and they can control the muscles with stimulations, and we can help them potentially to better control the stimulation of the muscle to match a human walking behavior in a smarter way. So yeah.
Kind of going back to the research, the methodologies, I'm just reflecting a little bit on the something that you said in the TED talk that you did when you were, the topic of which was socially aware AI. And you said something about like combining not only what we like the way humans behave, but also to some extent how they should behave. And I guess it's a little bit of a philosophical question around kind of ethics and how that plays into this whole system, because in a way, does what a philosopher believes is like an ethical way of existing in the world reflected in the data when you see how people actually do behave, and then going forward when we program these behaviors, what should be sort of our approach? So I'm curious if you could talk a little bit about that.
Yes, I love this topic. I think so I'm gonna also add some clarification. First, I think I use the word socially aware AI, and it's a bit different than ethically aware AI.
Mm-hmm. Yes.
Although we could sometimes say it's the same thing in some context. So the way I differentiate it is socially aware AI. At the end, I can describe it as an AI system that can model human interaction or understand human interaction, or knows how to predict the dynamics of human or what human will do around you. Ethically aware is an AI that is based on an ethic that is quite explainable and quite clear. And it's something that I don't have any surprise. I mean, it's not subconscious. It's something that, has a theory, has a principle, and I'm trying to apply it. And I can also teach it. For instance, there are some ethical principles that are quite obvious to our society, maybe. But maybe they're also putting them into practice is not.
Mm-hmm.
And the simple ethical principle is respect others. So when I develop a self-driving car, my car needs to respect others. Or if I have a robot that navigate the crowd, the robot must respect others. It's quite common. It's quite obvious. Our society have laws. I cannot hit humans. I need to respect them. So our robot must avoid collisions and must also, should not disturb others, right? So we want the robot to behave in a seamless way. Then, so this is a principle that we can inject in the car, right? But then maybe how to respect others or what is socially accepted, what is okay might change across culture, and that we can learn from the data. But the principal rules, the ethical rules, we actually know. We don't need to learn them from the data. We actually should impose to the system. And the most difficult one are, in fact, in self-driving car, we have all this dilemma, challenges, like ethical dilemmas, where these are scenarios that you hope they will never happen. They're extremely rare, but there is a very, very clear ethical dilemma, and there's this responsibility of the developer. What should be implemented if this happens, which as with a likelihood of 10 to the minus, I don't know, 5, hopefully. But still, do we have a duty to consider these scenarios and suggest an implementation, suggest an execution of something? And then the question is, what should be the ethics in these scenarios, and how can we ensure that the system will execute them and also execute them if the scenarios change a bit? And the thing that we are extremely we're also looking at is what is quite clear is that we don't have a universal ethic. We disagree. So we made this survey. Many people have done survey of here is 2 people in front of the car and 1 person in the sidewalk who the car should should turn or not, because there's no other options. Everything is blocked, and people will still disagree. So some people will say these 2 people in front of the car should not die because there are 2 people that you can save, but the person on the sidewalk is alone, so you kill less people, but you should turn to kill that person, although that person was on its right and is on the sidewalk. So there's a lot of these discussions, arguments that whenever we did the survey, people, it's very interesting to see that it's not, people will still disagree. And then the question is, okay, anyway, suppose that someone has an ethic, the same way that we do, right? When we drive, we all have our ethic and we follow it. Can we transfer that ethic into a machine and make sure that the machine will behave the same way as that person following the person's ethic?
I see. So are you saying there's like almost a world in which there, we can impose our individual ethical system?
This is an open question. Can we, or even at different scale, maybe a committee has gathered, with experts in humanity, that have studied philosophy for decades, and said, this is what the machine should do in this setup, or here is the ethic. Can we, as engineers, take basically their principles, their reasoning, and implement them in a way that the machine will always behave, take the right decision in these all these possible dilemmas that will happen in the future? And it's not very easy, because then the thing is, what should you ask this committee or this person, if we simplify, to learn about that person ethic? And how can we ensure that in all scenarios, this will be actually executed correctly? We can test on few scenarios, but maybe there will be, new scenarios that we did not think about it. can we make sure the machine will still follow the principle in the correct way? And we don't have an answer yet, but it's a very interesting thing to, can we automate, basically learn someone's ethic and automate its execution?
Do you think that there is fear around that? Do you think that that is something that is something that you think about in terms of pushback on kind of research and progress and innovation, that governments, that institutions will just be afraid to sort of try to sort of answer some of these very difficult questions?
Yeah, so I've asked, you ask companies, I'm like, okay, guys, so you're aware of the ethical dilemma in self-driving cars, there's a MIT moral machine. So what have you guys implemented in your system? And surprisingly, their answer is always, oh, these examples are not realistic, or they are not happening all often. We have other scenarios that we should focus on first, or we already fail in basic interactions, so we want to first solve this. And all these ethical dilemmas that are extremely rare, nobody really, it's not in our agenda right now. So, and the argument is, again, we should not suppose that someone will jump in the highway in front of your car, and that you need to do something ethical. And so maybe, I don't know if they are right or not, but
it seems
at least companies are not, and even I think the law government are still allowing to have self-driving car without necessarily answering these ethical dilemmas. Or maybe basic ones. Never collide with someone, things like that. Or follow, the path, and you should be able to follow the law and so on.
Yeah. I imagine, given that you've been studying human behavior and movements and prediction for such a long time, I think you're probably more attuned to this than probably most people would, just in terms of these scenarios and what can go wrong, and how unpredictable I suppose it can be. This has been fascinating. I want to leave, I suppose, a little bit of time for questions. So I'm just going to look over to the side and see if there are any. And then I guess maybe also just in closing, I don't know if this, my line of questioning hit on some points that you hit on, all the points that you are interested in discussing, but is there anything else that you think, you want people sort of to take away? And it's a pretty broad audience, but just curious if there's anything that, you want to draw particular attention to.
I think one of the most common also discussion and fear is about an AI system that will take over, us, and or take over humanity, or take over things like that. My view on this is, an AI system is an assistant that and that its creator has full control over it. So we humans are the creator of the AI system. It does not mean that the AI system will not do something that we cannot. So it can actually be smarter than us in some tasks. So for instance, a calculator is much smarter than me in doing calculation, but I have full control on it. I can decide to, the range of calculation that I allow it to do, even the range of numbers that I want the calculator to use. And it's accepted for me that this is not dangerous. So it's always possible to create a system that is dangerous, but it's because the creator allowed it. If the creator puts boundaries or check, or there are regulations, it will never take over us by its own because it's too smart. There's not such a thing as the system is too smart, hence it will take over. it's really us that we need to make sure that we program something that makes sense and that is in a set of output space or actions that is accepted by our society. And the main difference between a machine or AI system and humans is the concept of free will. It's a philosophical concept, but the reason that we humans can potentially do bad stuff or take control or it is actually our free will. I mean, we have the free will to do potentially whatever we want. It's a philosophical concept. People will disagree. Maybe we don't have free will, we're deterministic or not. But at the end, when I'm sitting in a bus and an old lady comes, or man or whoever, it's up to me to decide to leave my seat to that person or not. So it's my own personal decision, ethics, that will make me get up and let someone sit in my spot because I feel like this person needs it more than me. So I have absolutely free will on this. A robot, if it's sitting in the same position, will not decide by itself. So someone, the developer, will have to implement a rule for that. Say, either get up if someone comes or remain seated. But we need to provide this. The robot has no free will in making such a decision. So that's the difference. It's true for all the other applications. So for me, it's very naive to always talk about a robot has a consciousness or will actually take over. It's not such a thing. I mean, it's a machine that is executing things, and it will never have, because by creation, this concept are actually assigned to human beings that have this knowledge, these faculties.
Yeah. I mean, just, thinking about it, I mean, in a way, so much technology to date has really kind of obscured human free will. Like if you think about a bomb or any kind of weapon, it removes, it removes the need to use your physical hand to kill someone, which removes the humanity. But we have machines, we have things we've programmed. Sometimes we don't even see the face of the person we're killing on the other side. Sorry, this may be a little dramatic, but it makes me think when I think about what you're working on and the fact that it's movement, in a way, the attempt to make it much more attuned to human free will, to human ethical code, actually feels like we might actually, as we move forward, be a safer society. Maybe that's too optimistic of you, but
no, but it's not this technology that are making us not safe. It's the decisions to humans' ethics. Do they want to be, more human or not? Do they want to respect each other's or not? It's more educating humans' ethic and humanity. Honestly, we have done so much progress that if a human wants to harm someone else, they don't need AI, they don't need fancy technology, they can do it. They have enough tools. Everything is there already. So it's mainly, yes, reminding humans about their real origin and why they are here on Earth and what they have to do, and potentially, yeah. So
do you think, I want to end on a more positive or a high note as opposed to sort of our basis human instincts of killing each other. Do you think that over the last 10, 15 years, have you learned anything about yourself, about your own humanity and your own ethical code and how you move through the world by studying what you study? That's a difficult question. I apologize.
No, I think, I mean, what I study is actually quite basic with respect to mobility. So haven't learned something unexpected. What I mainly learned is um, that many things that are extremely basic for us is not that easy for a machine.
Fair enough.
But I'm extremely happy with the current trend of talk. A lot of people talk about ethics. A lot of talk about making sure to trust the system, regulating, having a lot of check, a lot of validation. This is great. So we need all these things. We need to have people that are making sure that we don't do things without thinking about their consequences and the same way that in the medical thing there are all these FDA approval, there are committees to validate whatever you want to put in contact to humans. We should have the same when we develop any technology in this case AI systems.
And are there any needs in terms of your lab and resources? Are there bottlenecks to sort of progressing your research, or do you feel well equipped and well staffed to continue doing your work?
Sorry, I didn't.
Oh, just in terms of like putting an ask out into the universe, if there are things that you wish you had in terms of more resources or, you know, certain types of talent, or do you feel sort of optimistic and excited to move into the new year, with everything that you have?
No, are you asking me for a Santa wish list?
Yes, exactly.
What do you wish for
I'll
Christmas?
try my best. I have to
Ooh,
deliver.
awesome. No, I think we are. It's amazing. I'm in a field that is quite trendy, and everybody is talking about it. And even young students are fascinated by it, and they want to work on it. So it's amazing. It's awesome to work on something that many people are interested to work on. And the best that we can hope is that they keep their motivation, and that a student wants to, or researchers, they want to have any positive impact on our society and help us to be able to develop our humanity at the end, to assist us to develop more our humanity. So yes, so far I think we're quite fortunate. We are attracting a lot of people in the field, and the more diverse these people are, the better it is. So I think it's also very important to make sure that diversity is preserved in this effort on making decisions.
Amazing. Thank you so much. And yeah, I hope to see you very soon. And in the meantime, have a wonderful holiday, New Year, and thank you again.
Thank you. Have a great day.
Okay, take care.
Yes. Bye bye.